8.2 Equilibrium of rigid body. So the learning objectives is to define and use torque. Torque is equals to R cross F. So this is actually the cross product. Okay, and then solve problems related to equilibrium of a uniform rigid body. Okay, so rigid body is an idealization of a body that does not deform or change shape. Satu badan, rigid body, yang mana bila dikenakan force ke atas dia, dia tidak berubah bentuk. And then equilibrium, okay, bermaksud the summation of F acting on the body is equal to 0 and also torque equals to 0. Okay. Okay, some of the examples for equilibrium of rigid body is this one. So the rigid body is the beam. So this beam is hanging and in stationary condition. Maksudnya kita tengok dia tidak berputar ataupun tidak bergerak on any axis. Okay. And then another one is a ladder rests against a wall. Okay, tangga ni dia tidak bergerak bila kita sandarkan dia pada dinding. Okay, and another example is the seesaw. Okay, in the picture, the seesaw is balanced, which means that the torque from the left side is equals to the torque on the right hand side. Okay, so dia akan balancekan seesaw ni, dia jadi straight line macam ni lah. Okay, so what is torque? Torque, or also known as moment, is the size of turning effect produced by a force. So torque is the tendency of a force to rotate an object about an axis. Kecenderungan daya untuk menyebabkan putaran sesuatu objek. Right, so we know that torque is a cross product. So bila cross product, the maximum torque we will obtain when the angle is 90 degree. So kalau cross product, we can also write in another form, which is Fr sin theta. So sin 90 will give us the maximum value of the torque. Okay, consider that we have a rigid body. So yang biru ni adalah rigid body. And then there is a force exerted at point P. Ada force dikenakan pada titik P dalam keadaan angle theta. Okay, maksudnya the force is not along Y or not along X. And we can draw the line along the vector F. Okay, this one, in which we call this line the line of action. Garisan daya. Okay, and then point O is the point of rotation, meaning that if the force is applied to the rigid body, this rigid body will have the tendency to rotate around point O. Okay, so then we can draw the moment arm. Moment arm starts from the point of rotation to the line of action. Okay, and then D is the moment of arm, must be 90 degree to the force. Okay, so F times D. Okay, which is D is R sin theta. We resolve R and we get D. Therefore, we can replace R sin theta with the, this is another formula for torque. So FD. The condition is that the angle between F and D must be 90 degree. Okay, so they must be 90 degree to each other. So torque is a vector quantity. And then the unit for torque is Newton meter. Newton from F and meter from D. Newton meter. Okay, refer to the animation. The maximum torque is when F is perpendicular to the D, which is the moment arm, and the value will decrease until F becomes parallel with D. So sin 0 equals to 0. Okay, the sign convention for torque can either be positive or negative, depending on the direction of rotation. So for rotation to occur, there must be one point acts as the pivot, menjadi titik putaran lah. Okay, for example, the triangle over here is the point of rotation. So we have force going down. Okay, so this is the line of action for the force. From the line of action, draw a line directly to the point of rotation. Kita akan dapat moment arm. Okay, so from there we can see the rotation is going clockwise. And for clockwise, we say that torque is negative. Okay, next, the same thing from the point of rotation over here, the straight line to the line of action, 90 degree to the line of action is the moment arm, and then this is the line of action. So from here, we can see that the direction is anti-clockwise. For anti-clockwise, the sign convention is positive. Okay, so to help you remember this, you can imagine that you have axis, X and Y. And when we show the angle, we start from positive X, right? So the angle would be, for example, here would be 45 degree. Here would be 0 degree. Okay, so if your rotation starts from the positive axis going in the anti-clockwise direction, we say that the directions of the torque is positive. Saya ulang balik. Kalau kita baca angle, kosong kita bermula pada positive X. Okay. So, dia sepatutnya kosong pergi ke 90, 180, 270, 360. Okay. So, kalau arah putaran torque awak ikut arah kita baca angle, okay, jadi kita kata dia positif. Okay, so the idea of torque depends on the radius of the rotation, the magnitude of the force, and also the angle between the two vectors. Okay, so let's first look at the angle. Okay, so in this case, the first diagram over here, R and F is parallel. Okay, so we can say 0 degree or 180 degree. And that will give us sine 0 equals to 0. So which means this is torque minimum, 0. Okay, how about the diagram on the right hand side? So the angle between R and F is 90 degree. Okay, so sine 90 is equals to 1, which is this one will give you the maximum value of the torque. Okay, so the concept that you have to remember is that the R and F should be 90 degree in order to get maximum torque. Okay, now we focus on the effect of R on the torque. Okay, as you can see, there are two diagrams over here. One with a bigger R and this one with a shorter R. Okay, so when the R is small, the torque will become small. If the R is big, torque will be big. Okay, this shows that with a force of a given magnitude, a door is easier to open by pushing at the outer edge than by pushing closer to the axis of rotation. So your hand must be far from the axis of rotation. Baru senang nak buka lah. Kalau dekat, susah nak buka. Okay, another example to show the effect of R on torque. Okay, this diagram over here. Even though the same force is used, the torque applied to the bolt increases as the distance from your hand to the bolt increases. Okay, bila R kita besar, torque kita besar. Torque tadi kita kata adalah tendency of an object to rotate about an axis. So, dia ada tendensi yang lebih besar untuk berputar. Okay, next, let's consider that we have a rigid body. So, this is the rigid body. So, to draw the FBD for rigid body, kita tak bermula dengan titik lah. Maksudnya, kalau sebelum ni awak belajar vector diagram, daripada titik tu kita tarik di mana force kita. Okay. But for rigid body, we will label the forces according to the diagram. So, for example, this one, W2, somewhere around here. W1, here. And here we have FR going up. Okay, so FR is at point O, the point of rotation. Okay, so let's say if the point of rotation is at point O, okay, dekat sini. So each weight over here will cause the rigid body to rotate. Okay, so first, let's look at the line of action. Okay, this is the line of action for each forces. From the line of action directly towards the point of rotation is what we call as D, the moment arm. So this is the moment arm for the first weight. Okay, and then on the right hand side, from the line of action 90 degree to the point of rotation is the moment arm for weight 2. So FR is exactly at point O. So dia tak ada moment arm, dia tak ada D. So to calculate the torque caused by weight 1, this one, okay, and for torque 2 is W2 D2. Okay, but then torque for FR is equals to FR times 0. So the D is equals to 0, which means that we don't have torque for FR. Okay, how about the directions of torque 1. Okay, so we can see that this is the D, W weight is going down. Okay, so it will have the tendency to rotate anti-clockwise. Anti-clockwise is positive, so this one would be positive. Right, for T2, this is D and this is the weight. 2, so the tendency is to rotate clockwise. Clockwise is negative. Okay, so if the question mentioned that this rigid body is in equilibrium, okay, which means the summation of torque is equal to 0. So torque 1 plus torque 2 equals to 0. And then we know that torque 2 is negative. So torque 1 plus negative torque 2 equals to 0. Okay, so the concept that you have to remember is equilibrium of rigid body happens when the summation of F equals to 0. Okay, F boleh jadi Fx, Fy or Fz. And then the summation of torque equals to 0. One of the example is lampu di siling. So lampu di siling awak tengok dia static di situ dan tidak berputar-putar. Okay, so bila dia tidak berputar, torque equals to 0. Then dia tidak moving dekat X ataupun Y, summation of F equals to 0. Okay, the sign convention for torque, positive, okay, when it goes counterclockwise or anti-clockwise, negative is clockwise. Okay, the formula for torque is Fd. If you want to use this formula, make sure F and D is exactly 90 degree to each other. Okay, and then RF sin theta. This one, you just put the angle lah. This one, RF sin theta ni tak semestinya 90 degree. But then if you use this one, kena 90 degree to each other. Okay, let's look at example. Okay, calculate the torque at A. So A is the point of rotation. F is the force applied. So kalau kita lukis line of action dekat F, from the line of action, 90 degree dengan dia, distance pergi ke sini adalah moment arm. So to calculate torque is equals to Fd. Okay, F dan D ni mesti 90 degree. So 13 darab dengan 2, you will get 36 Newton meter. Okay, Newton daripada force, meter daripada distance. Or you can use this formula, T equals to RF sin theta. So R is 2, F is 13, sin 90 degree. You will get the same answer. Okay, so this is the magnitude. How about the direction? Okay, so because we see that the force is going down, therefore it will have the tendency to rotate clockwise. This one will be negative. Okay, so you can just put in a bracket clockwise. Okay, number 2, calculate the weight W if the system is in equilibrium. Okay, so let's first draw the FBD. On the right hand side, kita ada weight ke bawah. Kemudian kita ada weight ke bawah. Okay, and then we have weight over here. Okay, so to draw the FBD, we only focus on the rigid body. Sekarang rigid body kita adalah papan ni lah. Okay, so lukis semua force yang acting on this body. Okay, di mana dekat sini kita ada pivot. So, as the pivot is touching the body over here, kita akan ada R naik ke atas. Reaction force. Okay, so bila kita tengok pivot di sini, we know that this one will be the point of rotation. And the word equilibrium suggests the torque on the right hand side is equals to the torque on the left hand side. Okay, so let's focus for weight 1 over here. So from weight 1, this is the line of action. From the line of action, 90 degree to the point of rotation. So this is D1. Okay, 1.5. Right, then for weight 300 Newton. So this is the line of action, 90 degree from the line to the point of rotation. So this is D2. Okay, and then the same for the 550 Newton. Ini adalah line of action. From the line of action, 90 degree to the point of rotation. So this is D3. Okay, so from the word equilibrium, we know that summation of F equals to 0. Summation of torque equals to 0. So let's say this is the point of rotation dekat pivot. We can write summation of torque about point O is equals to 0. Okay, if we look at the diagram, we have D and then F going down. So this is going to be anti-clockwise rotation positive. Okay, this one for 300 Newton going down, D is here. So the rotation is clockwise negative. The same goes for the 500 Newton. This is the D. So the rotation is clockwise negative. Okay, therefore, we know that torque, summation of torque is torque 1 plus torque 2 plus torque 3 equals to 0. But torque 2 is negative and torque 3 is also negative. So we just substitute the value W1 D1 minus W2 D2 minus W3 D3 equals to 0. Okay, then substitute the value, you will get W1 is equals to 750 Newton. Okay, number 3, determine W and reaction force at O, assuming that this rigid body is in equilibrium. Okay, so kita assume dia berada dalam keadaan equilibrium, in which the summation of F equals to 0 and summation of torque is equals to 0. Okay, so for this kind of question, to solve the unknown, we can start our calculation by using these two. Okay, kita boleh guna dengan summation F equals to 0 ataupun summation torque equals to 0. It is the same as number 2, cuma untuk number 2 ni, kita hanya pakai torque equal to 0, dah dapat jawapan. Let's say if you didn't get the answer yet, you will need summation of F equals to 0 to get another equation. Okay, so let's look at in terms of torque. Okay, so now W is going down 90 degree from the line of action to the point of rotation is D. Okay, 1.2 adalah moment arm. Okay, on the right hand side, kita ada 15. From the 15 to the point of rotation, 1.6 is the moment arm. Okay, so here the rotation is going to be anti-clockwise positive. This one is going to be clockwise negative. Okay, so we can write summation of torque at point O is equals to 0. Torque 1 plus negative torque 2 equals to 0. So torque 1 is W 1.2 minus 15, 1.6 equals to 0. Then W is equals to 20 Newton. Okay, so we have found the answer for A, and now we go to B. So we can see that reaction O is along y-axis. So remember the summation of Fy is equals to 0. So what vectors do we have along y? Kita ada W, kita ada R, dan juga kita ada 15 Newton. So going up, kita letak positif RO, tolak dengan W, we have calculated 20, minus 15 equals to 0, therefore direction O is equals to 35 Newton. Okay, so basically what we have applied in all the examples is the condition, summation F equals to 0, summation torque equals to 0, and then we refer to the sign convention, positive and negative, and then use the formula of torque.